Serial processing is a type of computing in which a computer executes one task at a time. The central processing unit, that is the CPU, executes instructions sequentially, one at a time, until the task is completed. This means that the CPU will only start executing the next instruction once the previous instruction has been completed. In serial processing, there is only one processor or core, and it executes instructions in a linear order, following a single path. As in serial processing, there is only one processor or core available to execute instructions. This means that the CPU can only work on one task at a time. For example, if you are writing your essay on your computer and at the same time you try to download a large file, the computer will have to pause the essay writing task to download the file and resume the essay writing task once the file is downloaded completely. While serial processing is a simple and reliable method of computing, it can be slow and inefficient when dealing with complex tasks that require a lot of processing power. That's why modern computers use parallel processing, which allows multiple processors or cores to work on a different task simultaneously, resulting in faster and more efficient.
Now we see the applications of a Flyn's classification. Serial processing is commonly used in simple and single task applications where the data processing needs are not very demanding. For example, in a word processor, a user types in text and the computer processes each keystroke one at a time, displaying the result on the screen as the user types. Similarly, in a simple calculator application, the computer processes one arithmetic operation at a time, following a linear path. However, in more complex applications that require a large amount of data processing, serial processing can be slow and inefficient. This is because the CPU can only execute one instruction at a time, so it can take a long time to process large amount of data. Now we see parallel processing. Parallel processing is a type of computing in which multiple tasks are executed simultaneously. In parallel processing, multiple processors or cores work together to execute instructions, each processor operating independently. This means that multiple tasks can be executed simultaneously, which can lead to significant performance improvements compared to serial processing. Parallel processing can be done in different ways. One way is through parallelism at the instruction level, where a single instruction is executed simultaneously on multiple sets of data. Another way is through parallelism at the task level, where different tasks are executed in parallel by different processors. Parallel processing can be done using specialized hardware such as parallel processors or graphics processing unit (GPUs), or through software techniques such as multithreading, where different threads of execution are run on different cores. Parallel processing is commonly used in applications that require heavy computations such as scientific simulations, weather forecasting, artificial intelligence, and machine learning. Parallel processing can significantly reduce the time required to process large amounts of data, making it possible to solve complex problems that would otherwise be computationally infeasible.
Parallel processing is commonly used in applications that require heavy computation such as. However, parallel processing also has its challenges. It requires careful design to ensure that different processors do interfere with each other and that data is processed correctly. It can also be challenging to write programs that take full advantage of parallel processing, as programs must be carefully structured to divide tasks among multiple processors and ensure that data is shared correctly.
Flyn's classification is a way of categorizing computer architectures based on the number of instruction streams, that is, the number of sets of instruction being executed, and the number of data streams, that is, the number of sets of data being processed that can be processed concurrently. Flyn's classification was proposed by Michael J. Flynn in 1966 and hence has become a widely used classification system for computer architecture. There are four categories in Flyn's classification: single instruction single data (SISD), single instruction multiple data (SIMD), multiple instruction single data (MISD), multiple instruction multiple data (MIMD).
SISD means single instruction single data and SIMD means single instruction multiple data. First one is single instruction, single data. This is simplest type of computer architecture in which single processor executes a single instruction stream and operates on a single data stream at a time. This is most common type of architecture and used in most personal computers and workstations. Single instruction multiple data means SIMD. In this architecture, a single instruction is executed simultaneously on multiple sets of data. This type of architecture is commonly used in applications such as multimedia processing and scientific simultaneation, where the same operation needs to be performed on a large scale of amount of data. In SIMD architecture, there is a single processor that executes the same instruction on multiple data streams in a parallel. This type of architecture is used in applications such as image and signal processing.
MISD, which is multiple instruction single data, is a parallel computing model in which multiple processors or processing unit execute different instructions simultaneously on the same data. In this model, each processor or processing unit operates independently and performs its own unique computation on the input data. The architecture is rarely found in practical implementations as it does not have a significant advantage over other architectures and is not widely applicable. The next one is MIMD, which is multiple instruction, multiple data. MIMD architecture is a parallel computing model that involves multiple processors or processing units, each capable of executing different instructions and operating on different sets of data independently. Unlike MISD, MIMD architecture is more commonly used in various parallel computing systems such as multiprocessor systems and distributed computing environments. In MIMD systems, each processor can execute different instructions and process different data simultaneously, allowing for high levels of concurrence and parallelism.